Now we're going to look at the sum of a finite arithmetic sequence. Finite because it's going to stop at a certain number. You're going to have that last term. So we're going to look here, the sum of an arithmetic sequence. You can always use this pattern where it says whatever your a sub k is, as long as you know your n, so the number of terms that you're plugging in, and you have your first term, you can then find the sum. So the formula that we're going to use probably most often is right here, and that's n over 2, so n divided by 2, times the quantity of your first term plus your last term. All right, so let's look at some examples here in finding the sum of an arithmetic sequence. If we first define our first term on this first sequence is a sub 1 is our -8. Our last term, which we'll call, would be your a sub n, is 27. And let's see which, what is n here. If you count up the total number of terms, you have 1, 2, 3, 4, 5, 6 terms. So that was your a sub 6 is 27, and your n is 6. All right, so if we look at our sum here using our formula said n divided by 2. So we have 6 divided by 2 times the quantity of your first term, which is -8, plus the last term, which is 27. And when I work this out, 6 divided by 2 is 3 times -8 plus 27, that's 19. And 3 times 19 comes out to be 57. Now, if you were to take in your calculator and just add up the terms that you have, -8 plus -1 plus 6 plus 13 plus 20 plus 27, you'll see that you come up with a sum of 57. So using the formula can be much quicker, especially when you have an example like the one on the right here, where we've got 4 terms listed, but you see the ... in between 105 and 27, meaning I don't see the entire list. I can't just use my calculator and add up all the terms because I don't know what all of the terms are. So we're going to try and define what we have, and then we're going to have to find a few things so we can use the formula. We have our first term here, so our a sub 1 is 111. We have our last term, so we could say our a sub n, which we don't know what that n is yet, but our a sub n is 27. And if you look, we have to figure out what our n is. So in order for us to find the n, we're going to need to go back to writing our explicit formula from section 9.4. The explicit formula says that you have a sub n is equal to your first term, which is 111, plus n minus 1 times d. Well, we have to find our d. And if you remember, on an arithmetic sequence, d was found by taking the following term and subtracting the previous term. So if I look at 108 and I subtract 111, I have a difference of -3. So I'm going to substitute -3 in here for d. So I have a sub n equals 111 plus n minus 1 times -3. The -3 needs to be distributed to the n and to the -1. So you have a sub n is equal to 111 plus -3 plus 3. Adding our like terms, you get -3n plus 114. Okay, so we need to solve for n. We know our a sub n in this sequence that they give us, our last term is 27. So we're going to substitute 27 where you see a sub n. And now we're going to solve for what n is. So subtract your 114. You're going to get a negative 87, I believe. Divide by negative 3, and n is going to come out to be 29. Okay, so if I were to write this in sigma notation, I'm going to do this just for the practice of it. I'm going to take, here's my sigma notation. This says starting at 1, going up to 29, because that was how many terms there are. I have my formula, which came out to be negative 3k plus 114. All right, so if we want to find the sum here, that said take your first term, which was 111, plus the last term, which was 27. That's in parentheses. And we're going to multiply that by our n divided by 2, which was 29 divided by 2. When you work this out, our sum is going to come out to be 2001. All right, down at the bottom, there's a try there where it says 2, 4, 6, 8, all the way up to 70. I want you to go ahead and pause the video and try this problem, and then when you're done, unpause the video and come back and see if you've done that correctly. Okay, hopefully you've done this work correctly, and you notice here on the last example and on this example, I've written both problems in summation notation. The reason I did that is because there is a way to check these on your calculator, but you need to have them written out in sigma notation so that you know what your a sub n formula is. If you look down here at the bottom, I have the steps written out. You want to write these in your notes in order for you to go ahead and be able to check your work as you're going through. Notice here I said on the calculator you need to have your mode in sequence. If you don't have it in sequence mode, it's just going to take your variable as x. It still will work, but if you put it in sequence mode, then you're going to see n when you hit that variable button. Okay, so you want to go to second, then stat, then math, and the fifth choice down is the word sum with a parentheses. Then that takes you back to your main screen. You want to hit second, stat, ops for operations. The fifth one down now is sequence, S-E-Q, with a parentheses. And that's going to take you back to your main screen. Then you want to type in your a sub n. Whatever that explicit formula is that you have, you're going to type that in, hit comma, then you're going to hit your variable button. That's going to plug in n if you're in sequence mode. Another comma. You want to put your starting number. So what's your lower limit of your summation? Is it starting with 1? If it's starting with 1, put a 1 there, hit comma. And then your ending number, so whatever your upper limit of your summation is, the number that's up on top of that sigma notation. And then close the parentheses and hit enter. On your screen, if you were to type this last one in, you would see it as sum, parenthesis, sequence, parenthesis, 2n, comma, n, comma, 1, comma, 35, and then 2 sets of parentheses. And when you hit enter, it should come out to be 1,260. Okay, this concludes the arithmetic sequence, or finding the sums of arithmetic sequences.